Okay, here we are. From yesterday. All I've done so far is right down here with the absolute value function. I've said that I want to define this guy, the absolute value, in pieces. I'm not going to define the step value function because there are infinitely many steps. That would be so annoying as a piecewise function. But the absolute value, only 2 pieces, super helpful for calculus. And I just asked the question and people were just starting to answer, why am I using 0? Now pause. Did you guys catch the word that I used? What did I call 0? Separator. And I think a lot of you totally knew what I meant, even though you might not have ever called it that before. So who would be the separators in this guy? C and D. Now, that's not because this is a super snazzy like math term and everybody in the world uses it. I have no idea what people use. I don't even know if they do, which is why I kind of made up, she's alive. We got both of them back. Which is why I made up a name, because there are many times, especially, well, no, in both classes, pre-calc and calculus, when I have to talk about this guy specifically, I call them separators because if you were to think of a number line, more specifically an x-axis, these are the guys that are splitting up or separating the different branches in the domain. So on one side of C, it's splitting up or it's separating the different branches, splitting up the number line, splitting up the domain. On one side of C, this one branch, G, is occurring. In between C and D, another branch is occurring. And on this side of D, another branch is occurring. If you were to graph a piecewise, you'd have to actually take your x-axis, split it up with the separators, and then think, okay, I just want that graph for one part, then I want that for the other part. Anyway, that's why I call them separators. Let's go back really quickly, though, to the question, why was 0 the separator? And a lot of you guys were giving good answers. Jason, why is 0 the separator? Perfect. Because absolute value treats the negatives and the positives completely differently. Now, some of you are like, no, it doesn't. It does the same thing. No, it treats them completely differently. What does an absolute value do to a positive number? This piece. It keeps it the same. It doesn't touch it. So if you put in a positive x, it's still the positive number. Nothing changed. So I'm going to put an x right here for this piece. So for positive numbers, I put in and nothing changed. X is x. It's no big deal. Plug in a positive 2, it's 2. Plug in a positive 7, it's 7. Plug in a positive 11, 11. Absolute value in Algebra 1, you probably learned, is like the distance from the 0 on the number line. It's the magnitude or the distance away a number is from 0. But positive numbers stay the same. Now, what is completely different about a negative number when you plug it in? It flips the sign. Mathematically, what can we do to a number to flip the sign? Don't add a negative, but multiply a negative. If you multiply a number by a negative, the sign's gonna. So does it make sense, even though it's going to be really weird in your brain, that absolute value is sometimes opposite a number, negative a number, and sometimes it's the number itself? People hate this definition because they're like, absolute value can't be negative. Yeah, it can. A negative times a negative is a positive. It has to be negative. It has to be opposite. So you can think of it, even though you have to write a negative down, it's technically absolute value is opposite x when x is negative and x itself when x is positive. Does that kind of make sense? Okay. I know it looks weird, but it's totally legal because these are negative numbers, and a negative times a negative will be a positive, which is what you do. Okay, anyway, way more helpful than that, although this your brain is totally in tune to, and so in homework it's going to be easy when you see it, when you work with it. And in Algebra 1, we weren't teaching you piecewise functions, so yeah. That's why you haven't seen it earlier. You might have seen it last year a little bit. But let's zoom in on this graph really quickly, on these graphs, because the step function, I'm not doing the piecewise thingamabobs, but we better look at them and see what's going on. Step function has another name. In other books, it would be called the, ready, I want you to write it down, greatest integer. The step function is sometimes called the greatest integer function. My T got lost, sorry. Greatest, we know that word. We're probably too good at that word, actually. Integer. What kind of numbers are integers? I just heard so many answers. What kind of numbers are integers? Not rational numbers. Well, I guess some of the rationals are integers. Not all of them, though. Anybody know what I'm doing? You guys remember this from Algebra 1? Real, irrational, rational. Oh. I think I even did it probably in this exact same spot in Algebra 1, Jordan. Irrational, rational. What was next? Integers. Yeah, we did. Natural. Whole. No, wrong way. Wrong way. Natural was first. We didn't learn that. No. We didn't learn that. But whole. And then natural. It's all the different types of numbers. So over here in imaginary, you have like stuff with eyes, right? You have like square roots of negative numbers, like 17. I don't know. I made it something up. Real numbers. I think technically irrational could be like on an outside. Irrational would be something like pi. Irrational would be something like square root of 2. Some nasty decimal that's super long and never repeating. Rational could be something like 1/3, like a fraction. It could be like a decimal that's repeating, like 0.6666666, which is like 2/3. Integers, ooh, that's what we're talking about right now. Natural numbers are like 1 and 2 and 3. Only positive numbers. Whole numbers, anybody remember what's included in whole? Yeah, whole, you add a 0. So it's 0 and all the 1s and 2s and 3s. Integers, what's added? So you have the, yeah, negatives and positives. But not all negative numbers, just the negative counting numbers. So other negative numbers like negative root 5 would be out here in irrational. Negative 2/5 would be here in rational. Rational, ratio fraction. Natural numbers, just like the natural, oh, there's 1, there's 2, there's 3 of these. Whole, oh, 0, integers, negatives, and positives. Anyway, why am I saying that? What are we talking about? Integers. So integers, positives, negatives, 0. But no fractions, no decimals, no weird like pi numbers, nothing imaginary for sure. Huh. So, question. Can you guys tell what's the y value when x is 0? How about when x is 0.7? See it? Still 0. How about 0.99999999999? How about 0.1732? 0.1732. Still 0. What does the greatest integer do to everybody in between 0 and 0.9999999, or between 0 and 1, not including 1? It makes the y value 0. Why? Well, how would you write all those numbers I just said? Now, hold on. I'm going to put it in a little step function. The greatest integer of 0, we just saw was 0. But let me put in some other ones. I did 0.7. I think that was the next one. I did 0.9 repeating, although I stopped it, but I don't want to write all those 9s. Then I did something weird like 0.1732. Is that what I did? Thanks, Matthew. What does the greatest integer do to all of these if they're all just 0? In middle school math, how were you taught to write these numbers? Are we supposed just to write them 0.7, 0.99999, 0.1732? Maybe your middle school teacher didn't make you do this, did they? 0.7? 0.99999? Did they not make you do that? 0.1732? What's the greatest whole number, positive or negative, in each of these values? 0. What's the greatest integer in each of these values? 0. Oh, okay. So question, without even having it on the graph, because the graph doesn't go far enough, what do you think would be the greatest integer of, or the step function of 5.1? What would that become? 5. Good. How about 4.7? What's the greatest integer? 4, because it hasn't gotten up to 5 yet. How about, life is about to get hard. Hold on. Use the graph. I just did, what, 5.1 and 4.7? Let's just do one of them. We'll do both. That one became a 5. What's the greatest integer in it? 5. What's the greatest integer in it? 4, not rounding up to the next number. So think rounding down, rounding down, rounding down. Look at the graph. My question is, what is the greatest integer then of negative 1.5? A lot of people would say negative 1, and it makes sense based on how the positives worked. But look at the graph and look at the pattern. Negative 1.5. It's negative 2. Now some of your minds just kind of are like, oh, this function's, oh, sorry, not negative 2. I put the answer. Negative 1.5. The steps work exactly the same. And we look at the steps, right? They're exactly the same distance apart, the same like filled in on the left and then empty on the right. It's empty on the right because as soon as you get to 1, pop up to 1. As soon as you get to 2, pop up to 2, 2.0. But negative 1.5. Oh, why are negatives weird? Because it's going backwards. Instead of building up to higher numbers, it's going backwards to higher numbers. Well, not higher. Actually, they're lower. They're more negative. But I want you guys to realize that the pattern is exactly the same because every time you're rounding literally down. Literally down. What do I mean by that? All of these decimals got rounded down to 0, to the number right before, like on the number line. All of these, 5.1, 4.7, all got rounded down to the number previous or prior on the number line. Where did this get rounded? Down on the number line. Do you see what I mean? So in your head, you're like, it's up because it went to a 2. But no, we're not talking about the absolute value. We're talking about the actual number on the number line. So technically, when you learned in elementary school or even middle school math about rounding up and rounding down with decimals, etc., negative numbers, technically, your rounding up is really rounding down. Mind blown. But all that to say, the pattern's the exact same, but when does it get hard? Negatives, if you're not thinking rounding down on the number line. Jordan? Yeah. And negative 1.01, still negative 2. Does that make sense? And negative 1.9, same thing. So let me ask you another one. What if I was to ask you for the greatest integer of the step function of negative 4.7? Say it loud. Negative 4.7? Negative 5. Oh, sorry. No, you're good. You're good. It's ironic that you knew exactly what you were hearing, though. Negative 4.7. Negative 5, because it needs to round down on the number line. Does that make sense? Most people would go negative 4. No, that's rounding up. I need to go down to negative 5. Cool? Do you need me to go through this one and say, hey, what's the absolute value of negative 4.7? Oh, no. Ah, guys. Ah, where are you? What's the absolute value of negative 4.7? Okay, I didn't think I needed to practice this. What's the absolute value of 0? What's the absolute value of 100? Absolute value of negative 100. Okay, we're good. So, this homework, due tomorrow. Sound good? How many of you guys are at least halfway done with it already? I didn't want to know. Wow, you could have done that whole homework last night, you crazies. How many of you guys did other homework besides math last night? Aha! So what's tonight? There you go. Word to the wise, maybe split it up again, or not again, in the future. Okay. This class, we did not pick up our quiz reflections or test reflections yesterday, right? Grab out your test reflections. Sorry, in my head I just remembered that I had kids in the back taking tests yesterday, and that's why I didn't pick up the reflections. Now some of you are like, oh, so we get back our... Give me one more day. I was really focused on jury duty, having sub-plans, etc. yesterday. I'm sorry. Test you'll get back tomorrow. Wesley, can I borrow yours just to show it? This is what I'm looking for. The reflections that you guys were doing Thursday night over the weekend. I gave you one more night yesterday to do. We're going to go over the brain teasers. Now's a good time. We're at the end of 1/6, starting 1/7. Anybody else need to run to their locker to get it? It's in a different binder. Okay. So, brain teasers on the back. Flip to the back side. Well, let's look at the front side really quickly. Why did I give this to you? When did I give it to you? This is the most important piece. When did I give this to you? Right after the test. What was I looking for? Your immediate gut reaction on how it went. Why was I looking for immediate gut reaction? First of all, it's making you guys think about topics on the test and being like, oh, hey, she tested me on this and this and this, and I got this and this and this, and ooh, I didn't get this and this and this. So if there was a problem on the test that your brain already, like you have a place to put it and show me, like, I didn't like that one, or I didn't get that one, or I don't know that one. Okay, so it's immediate, like, yay, I felt really good about these types and I didn't feel really good about those types. It's an immediate reaction to the test. Why do you think I'm asking about how I studied? Or, no, I want you to be honest, or that you didn't prepare, right? If you have a huge long list, but then you're honest and you're like, but I didn't study. Maybe in your brain you're like, oh, this is going to be longer when I don't study. And I'll get more if I study. Some of you just, I don't know, math, you're used to not studying. Some of you, Algebra 2 kind of kicked you in the pants a little bit, and you're like, no, I have to study for my math test. Good, keep doing that. But this is honesty hour. This isn't you trying to be like, I'm an amazing student. Oh, by the way, I didn't get anything on the test. Okay, if you're studying, if you're doing the chapter reviews, you should get some things. Maybe not everything, maybe not many things, but you should be able to have some things like domain. Okay, I studied that really hard. I should have gotten domain right. Okay, so anyway, honesty hour, how you actually studied. What's the action plan for? Yeah, and it's not so much mistakes on like a particular problem. That's what the corrections are for. That will do when you get back your actual test. This is more just kind of taking the whole thing in and saying, oh, I didn't feel good about very much. I think my studying plan didn't really work out so well. Or, hey, I felt really good about everything. Next time, I think I'll just do the same thing I did this time. Or anything in between. Okay? So the action plan, it could just be like, you know what? I think the review really helped when I did it 2 days before. The action plan could be like, I need to start the review earlier because the night before is not a great time to figure out whether or not I get it. Yeah? So action plan, what am I trying to make you do? Plan ahead. Make a goal. And then hopefully you can have an actual thing to attain to or to achieve, or like motivation to say, I told myself that I needed to do something differently for next test. Then when I get this back and the tests are graded, we'll go ahead and put the test score on this and get it back to you, and then you can say, wait a minute, okay, hold on. Can't we sometimes reflect but like put ourselves in a better light or a worse light than we really are? Has anybody ever done that before? Like if someone else was to hear whatever's going on in your head, they'd be like, wow, you're being way harsher to yourself than you should be. Like sometimes we just don't give ourselves grace at all. And sometimes we're like, if someone else heard the thoughts going on in our head, it would be like, you have no clue what you're really like in real person. So the score is just to be like, okay, how self-aware were you? Like, are your feelings about math really translating to how you're doing on the test? And if not, okay, let's find the disconnect. And that might be something where you come talk to me and be like, I felt great. Like, I don't get it. Why did I? And it could just be lots of little mistakes. It could be killing animals. It could be things that you're not studying, or you're studying wrong. Maybe your notes are kind of off, etc. Anyway, so this front thing has all sorts of purposes, but the back is just to have some fun and to give you guys, for those of you that get done really early, something to play with. And for those of you guys that don't get done really early, to remind yourselves there's more to math than just what we're doing right now. And this isn't really math. I mean, it is, but it's more like a little logic puzzle, right? Okay, what was the first one? Top left. Man overboard. What's the second one? I understand. Third one. Reading. Yeah, reading between the lines. Does that make sense? Because reading is in between. Yeah. Oh, I didn't even think about that. Well, depending on your brain, yeah, you can see these totally differently. And to be honest, that's why so many companies like Google and well, Facebook, but that one's not very popular right now. But why some of these companies, they love having all these different types of people with all these different types of backgrounds, because then you get these unique perspectives. Anyway, Lauren's not bad. He thought it was a jail cell. Fourth one. Yep. Fifth one. Backwards glance, or I guess you could have said glance backwards, but backwards glance, like throwing back a glance. Backwards glance. Second row, we should be good at this one. There you go. Second one. Life after death. Ooh, that's a good question. Why is there a phone call? Third one. Going on a diet. Fourth one we'll come back to. It was kind of hard. You guys might not even know what it is. Fifth one. Tricycle. Hello? Yes. Okay. Bye. Nehemiah, it's for you, but you already know you're packing up. Thanks, bud. How about the third row? Banana split. Ooh! Because the banana is split. Banana split. How about the next one? Lazy afternoon. It's a lazy afternoon. Next one. Oh, did you get the next one? The next one's hard. Incomplete pass. No, that one's hard. I was thinking it was a spa, like something to do with like mixed up spa, and I was like, I don't know, I can't think of anything else. I got stuck on the spa part. French? What do you think it was, Wesley? Oh, so then you were thinking it was like a totally different word. That's, I see, I wouldn't have thought of that because I don't know French. Je ne comprends. Okay, how about the next one? Jack in the Box. Look, because there's B-O-X and then Jack is in between. It's brain puzzles. Brain puzzles. And especially if English isn't your first language, like these would be so hard. So that's why we're going over them too. Jack in the Box. Okay, hold on. Matthew, you're not allowed to say anyone's for a while, but you're doing a great job. Hold on. You can chime in if they have any questions. How about the next one? Oh, shh. Give him a chance. No one had it? Aww. Good job, though. Okay, give him 5 seconds. Okay. But yeah, double cross. Double cross. I really like the next one. Hold on. Give him a full 5 seconds. Some of them didn't even know what they were doing. Yeah. There you go, Tyler. Excuse me. Think of it. Excuse me. Get it? Excuse me. Okay. Next one. Tuna fish. Yeah, I like that one too. Took me a while. There's two fishes. I like that one. You guys are party poopers. Okay, the next one. Long time no see. A-B-D-E-F. No see. Long time no see. Okay, hold on. Someone has to have the next one besides Matthew. What's about the next one? Yeah, who said it? Oh, no, you're close, though. Go ahead. You're under arrest. Your rest is under. Your rest under. Yeah, the order's weird. The order's weird. Rest should have probably been on top. Your. Oh, that one is rough. Okay. I don't like that one as much. Okay, hold on. Someone has to have the next one. There you go. Big deal. I really like the next one, too. What's the next one? Scrambled eggs, yeah. E-G-G-S. It's all scrambled up. The next one's kind of hard. The next one's kind of hard. Go ahead, Matthew. Yeah, you have circles under your eyes. Circles. Okay.
Those are eyes? Oh.
Roman numerals are the eyes, and then the circles are circles under the eyes. I know, like bags. I think bags is a more common. It used to be circles under your eyes, like you had the, like the puffiness. You know what I mean? But okay, dark circles. Someone has the next one. Come on. Yeah, foreclose. Like a foreclosure has forecloses. Sad words. And then someone has to have the last one. 6 feet underground. Yeah.
But how did you know like it was supposed to be big?
Because I had an example on the board and it had the. Oh, that would have been wrong. No, not in the original. I put it at the end of class.
It was there the day before, and I saw it. I was like, what is manboard? And then you gave this to us, and then I was like,
Oh, didn't I put I understand though at the very end of class for you guys? Some of you might not have realized it when you walked out. I put the I understand one because I thought that would help. Yeah, I don't know, some like youth groups and different people like do silly stuff like this too, like get to know you games and stuff like that. Which one? Yeah, read between the lines. All right, pass them up because I want to be able to see. Oh, sorry. Did anybody? It's actually not level up, but that's a really good one. That's a good one though. That is a good one because you're like the level is going up. That one should have probably been like a stair step. It's split level. It's split level. If you've ever lived outside of California, you might know what a split level house is. Maybe you wouldn't otherwise. Split level is where like you go in the front door and then you go down to like the downstairs and go up to like, yeah, well that's why. I've seen split levels like in Colorado, but there are a few houses that still go down and up, but, oh, do they? Yeah, split levels. That was that one. All right. Section 1.7, transformations. Shoop. Thanks. The homework tonight is just 1.6. 1.7 is due. Sorry, the homework tomorrow morning is 1.6. And 1.7 is not due until Thursday morning. There you go. But 1.7, we might not get to that example at the end after all, but we're going to get to it tomorrow. So thank you for filling that out in your bell work, your workspace. We're going to probably get to that tomorrow. Yes, except you need to necessarily write everything. I don't think so. What would I say that you should write? First of all, translations go with shifts. The shape doesn't change. It's called what's that word and why isn't it coming to me? There are transformations that change the shape and there are transformations that don't. I think it's called static versus dynamic. No, that's not it. I'll have to ask Mr. Che. It was in your Algebra 2 book. I can't remember the name for it. Rigid. It's a rigid transformation because the shape of the graph doesn't actually change. But here's what I would do. You do need your little function notation, like patterns of each one. I would get these. And I would get what's going on in the sense of vertical shift up, vertical shift down, horizontal shift to the right, horizontal shift to the left. I would get those parts down, just like the main idea of what's going on. But here's what I'm going to use for the entire section, and hopefully it'll help you. And that's why I'm really glad we're at least starting 1.7 today. Here's what I'm going to use for the entire section as you guys are writing. We're going to have vertical transformations. We're going to have horizontal transformations. And hopefully last year, you guys had to study for this, and it was like chapter 2 of Algebra 2. It came really fast. Hopefully in studying, you found that there are definitely patterns, like huge patterns to the transformations. And one of the biggest ones is that vertical transformations are always occurring outside the functions, and horizontal transformations are always occurring inside the functions. And so as you notice down here, the addition apart from a parent function, whether he's an x squared or a square root of x or an absolute value of x, whoever that guy is, adding or subtracting outside is going to be vertically affecting it. The adding and subtracting makes it a shift. Outside is the vertical. Inside is going to be horizontal. And one other huge pattern, this is a semicolon, sorry. Looks weird. Looks even worse, but that's okay. Vertical is what you would expect. I would put expected. And horizontal is always unexpected. If you get to know it really well, you'll expect it, but as far as just like the first glance, it's always going to be not opposite what you think, but different than what you think. Sometimes opposite, sometimes flipped. But the vertical one's going to be the expected change, and the horizontal is going to be the unexpected. So in shifting, if you see a plus on the outside, it's going to do what you think it does. It's going to go up. Addition is going to make it go up. Subtraction is going to go down. But why is this one unexpected? Subtraction makes it go, whereas addition makes it go. Now, I'm not going to make you write down anything else from today, but can we just see if these patterns hold up among the other types of problems? We're going to do some examples, etc. Reflections, he doesn't really have a backwards unexpected thing. Dilations do, though. This multiplication is on the outside, so it's going to be what kind of stretch or shrink? Vertical. And it's going to be by a factor of c. So if there's a 2, it's going to double. 3, it's going to triple. Half, it's going to cut in half. But this one's weird. It's horizontal. It's on the inside, but it's by a factor of 1 over c. So if there's a 2, it's going to be cutting in half. If there's a 4, it's going to be cutting in fourths. If there's a 1/2, it's going to be doubling. It's always flipped. So if there is something unexpected, it's going to be on the inside with the horizontal. Oh, non-rigid transformation. Right there. It's going to be unexpected if it's on the inside. Now, one other thing just to keep in mind for the whole section, as we get ready to do a lot more of it with examples tomorrow. Vertical, it's affecting the y's of points. Horizontal, it's affecting the x's of points. And this is the exact reason why when we talked about the parent functions with x squared, x cubed, square root of x, absolute value of x, 1 over x, I didn't just put the sketches, I put points. See you guys later. Alligators after wild crocodiles, section 1.6 done for tomorrow. I'm zooming right through. Bye, guys.